right, functions and graphs. All right, these first couple of problems are kind of like weird, I guess is the best way to say it, but it says to like write a formula for the function and then use the formula to find the indicated value of the function. So it'll say something like, this one's the harder of the two in my opinion. The height h of an equilateral triangle as a function. Y'all are getting the worst of my handwriting while I get used to writing on a tablet again.
That's okay.
As a function of its side. Oh, side length S.
Nah, I had that desk before I switched it out.
We'll just keep pushing it that way. I need to figure out where's the spot where nobody sits because I have one desk that nobody ever sits in. I need to figure out where that spot is and move it to that spot.
Yeah, I used to have that chair like in English class. Every time we go, every single time.
Actually, I do think they brought it down here from the English room.
Yeah, I was about to say. That was probably my C in English. Because I was missing that thing too. Every time you slap it.
It's so loud. Even if you just move it around.
Yeah.
Locked in.
All right, so we're going to be writing a formula for the function of an equilateral triangle as a function of its side length S. And then we're going to be finding the height of the equilateral triangle of side length 3 meters.
So is that like the word problem?
Yeah, kinda. It's like this is what you're doing, and then now actually like do it, basically. Yeah. So basically we have an equilateral triangle, and we know that obviously that means all the side lengths are the same, and then obviously all the angles are the same. That's not relevant here, but
We have to find height.
right. So I can drop this down here for this to be my height, and obviously I know that makes a 90-degree angle now. So this is all my side lengths here as a whole.
It's 3.
And then I know also that since every angle would be 60 degrees, I know that this angle here has to be 60, meaning this one has to be 30. Now, that's only relevant because I need the special triangles to help me figure this out. Now, if this wasn't an equilateral triangle, if it was like a right triangle, I really wouldn't need to do this. But because it's equilateral, we don't like just know the formula off the top of our head for equilateral, so we kind of need to be able to like piece it together. So at this point then we can say, okay, well the height, we want to relate it to the side lengths. So I'm going to just look at the side lengths here. Do you remember what the side lengths are for a 30, 60, 90 triangle by chance?
Root 3. And then 2. Or times 3, right? No, I don't know. Yeah, 2.
And there's one. What's the other one? You remember?
2, 3, 4. No.
So the side lengths are 1, 2, and root 3. So 2 is the hypotenuse side.
Double.
So basically, that's there. Do I have this backwards? Oh, I know what I have. And then hold on, let me do it this way. Let me actually just draw a triangle over here. That's a 30, 60, 90, so we can see it a little better. It'll be easier. Okay, so that's 30, 60, 90. So then this is 1. And then we've got, why did I just write a 1 there? This is 2. And then root 3 is obviously bigger than 1, so that means that one's going to be the one that's opposite of 60. And then this one is 1 over here. Now, the side length itself, this S is the whole bottom. So half of that is this value. So this is going to end up being
1/2.
1/2 S. I'm going to switch colors here so we can see it. So 1/2 S is that side length. So if I had to cut that one in half, I have to cut all of them in half. So then this is going to be over 2. This is over 2. So that just becomes 1. And then I've got my √3/2 for this part.
Would the hypotenuse be 1S or just 1? Since that's the side length.
Technically, it's just the number value. I was just showing why this one was this. It's half of S is this value. Yeah, I'm just correlating them. I mean, technically speaking, yeah, there would be S's there, but S would just be like 1 in our situation because we didn't have the actual values.
Yeah.
So now I can take that information that I've drawn here to come up with the height. And so the height would be,
√3/2.
yep. So, and we would put the S on there for what height is equal to because we need it as a function of S. So our height is equal to √3/2S. And then it says find the height of the equilateral triangle of side length 3 meters. So this is the first part that it asked us for. And then the second part would be to actually plug in 3 for S. And so we would have H is equal to 3√3/2. And since they gave us units, I'm going to put meters. I'm going to put a little, I don't normally put the little like period when I'm abbreviating, but just so that we can see that that's units and not like a variable, yeah. So those would be the 2 things it's asking for. Now, I think that's the harder of them because we don't just know the stuff about an equilateral triangle. The next one is a volume thing, so it's a little easier in my opinion. So the volume of a sphere, and I'm kind of abbreviating it for time, but volume of a sphere, that was not how you spell sphere. I just wrote square. Volume of a sphere as a function of radius, which realistically is how that's normally written. So that's not really requiring us to do anything. If I knew how to write the stuff for an equilateral triangle, then I could have technically done that, but most people don't know that, so that's why I just do it that way. And then we're going to do it for when the radius is 3 centimeters. Do either of you happen to know what the volume of a sphere is?
2 pi r cubed.
You're close. The pi r cubed part's right. This is a fraction.
Oh no.
Wait,
1/3.
think of a circle.
That's a cone.
Oh yeah.
It's a fraction.
Yeah.
Is it 1/2?
Nope.
Or is it 4 over? Jeez, bro. 4/3.
Yep.
I remember seeing that because like I just took the SAT and I looked at that formula sheet.
Wait, how was it?
Dude, reading and writing was confusing. Math was easy. Like it was like too easy. So I don't know if they messed something up with the test writers or whatever.
Who knows?
But
So then just plug in here and then simplify, and I typically will just leave things in terms of pi, so like the volume would be 36 pi, and I guess we should throw centimeters cubed on there for volume. So there's our 2 things there. Just a couple things here. We probably aren't going to do this whole section today, but just a couple things to note with this, that these kind of equations, not so much equilateral triangle, but like the volume of a sphere, a cone, a prism, or like a box, things like that, you're going to eventually need to know. I mean, I wouldn't stress about it right now, but I would be familiar with them because they don't give you those formulas when you get to the AP exam. So just things to be aware of. Identify the domain and range and sketch the function. We'll kind of just do a rough sketch, not like a exact one here, but 6, we've got y equals x squared minus 9. So more or less what I like to do when we're doing like a rough sketch is I like to just talk about what is the shape. So what kind of a graph would this be?
Parabola.
Yep, it's a parabola. And what do we know about the parabola?
Started down at 9.
Yep.
Well, shifted down.
Yep. So I'm just going to mark that that's 9, and I'm just going to draw it up like that. Obviously not perfect, but in a lot of cases what we're doing, they're very rarely asking you to specifically graph the object. They're usually asking you to give a rough sketch to answer a question about it. So I like to just kind of rough sketch some things that we've maybe historically put into our calculator. What's the domain of a parabola?
Domain would be anything greater than. Wait, domain is
All real numbers.
Yep, all real numbers. You can do it that way, or you can do negative infinity to positive infinity. Those are both like known notations, so either way would be fine. What about the range?
-9 to infinity.
Yep.
Or-
Well, -9, comma, or.
And it's
whatever is
including on that one.
Greater than.
Yep. So you can do it this way. They didn't specify which notation, so that's fine. You technically could say like y greater than or equal to -9, things like that if you wanted to. But typically we're going to use this kind of notation in here. I don't know if we'll get all the way through this, but 8. Y is equal to negative square root of negative x. So this is going to require us to think a little bit because a traditional square root function occurs up here,
Origin, yeah.
but this one has been reflected twice. So it hasn't just been reflected this way, like what our normal reflection is. It's also been reflected this way, aka it's been reflected in a sense over the origin. So this graph here actually is like that.
Like an x squared, but just like. Wait, not x squared. X cubed, but like.
Kinda, yeah. So like that part was just the original what I had in green. So this would be what this looks like at this point. And we could always do that by plotting points at 0, at -1. When I plug that in, that's a +1. Square root of that is -1. So we could actually plot a couple, disappeared. We could plot a couple points here if we wanted to and do it that way. Anytime there's something that you don't know what it looks like, throw a point in there, throw an x in there, and find out what y would be equal to. Because if you threw 1 in here, as soon as you throw a positive number, it doesn't exist. So, you know, okay, I'm in the wrong vicinity, so let's try the other way. So what would the domain of this one be?
Would it also be all real numbers? Wait, dude.
Can't go this
I
way.
hate this stuff.
We're going to do a lot with domain and range this year, so can't go farther than where it is right now.
So then it's from 0 to
Zero
infinity.
infinity. Negative infinity. Zero
Well,
to negative.
whatever this is called, I can't think.
Negative infinity.
No.
To 0.
Parentheses. Dude, I knew it.
And then just real quick, the range would be
From that point, which is.
-1, though. That point is -1, right?
well, that's where the graph would start. So can the graph ever come up here?
No. It's
So then it has to be
0
down
to
here.
0 to negative infinity.
And always just make sure you put it in the same order. So it's the same thing, just for the y values instead. So we'll have one more of these that's a little bit more challenging where we'll kind of talk a little bit about asymptotes, and then we'll do even and odd functions tomorrow. And then y'all can do the notes for the next day too after that. So